Today's project, I'm going to modify a Skil 12 volt 2 amp hour into a 7 amp hour power tool battery using these LG 18650 cells. Let's get started. Before I start the video, I've got to say, please don't try this. Messing about with batteries is extremely dangerous. So consider this just for entertaining only. What works for me could be a total disaster for you. Now that's out of the way, let me show you what I've got. This is the Skil 12 volt power tool battery, and this is one of the newest 12 volt battery from Skil. You can charge the battery using a conventional charger, or you can also use a USB-C charger and plug it in on the side of the battery here to charge the battery. This USB-C port can also be an output, and it can put out between 5 to 20 volts, and you can use it to charge other devices as well. And this is why I want to modify this battery to a high capacity battery for two reasons. Reason number one is obvious, right? I want to get a longer runtime for my tool. And reason number two, I can use this to charge another Skil 12 volt battery. Check this out. So I plug the wire into the USB-C port on this battery, and I plug it in this battery, and you can see the battery on the left is blinking. That means it's charging. The battery on the right, the LED stays solid, 2 bars solid, and it is charging this battery. How cool is that? This battery is 7 amp hour. This one is 2 amp hour. That means I can use this battery to charge this battery 3.5 times in the field without any power at all. Actually, I have 3 reasons, and the third reason is as important. 12 volt is very universal. There are a lot of things that run on 12 volt DC, including this pump. This plastic adapter, it comes originally with the battery, and this is for hanging the battery on the wall. But I have modified it, and it has 2 metal clips here, so that now if I insert the battery in here, I have a 12 volt DC output. Now I can use this battery to power a water pump. Whoops! Or I can use it to power a Turnigy charger, and I can use it to charge any lithium-ion batteries. There are a lot of things that run on 12 volt DC, so this thing is extremely useful. Let me first show you what's inside the original 2 amp hour battery. We've got Eve cells, and they are 2 amp hour 20p. So 3 of these in series. So what I did on this battery is that I removed the 3 Eve cells and put in 6 LG 3.4 amp hour cells. So these are in 3S 2P configuration, 2 in parallel and then 3 in series, and that is the model number of the cell. Total capacity of this battery is about 6.8 to 7 amp hour. Here you can see how I spot weld them together. So these 2 are in parallel, and then I connect this and this in series on this side, and this in series on this side. And in the middle we got the balance wire. So on this BMS there are only 2 balance wire, one on here, one on this side. That's it. This is one of the easiest and straightforward battery modification I have ever made. We also have this clear plastic here. This is for transferring the LED light all the way down there in the BMS to the outside of the battery, so you can see the light out here. So press this button, you can see the light out here. Otherwise you won't see the light because it's all the way down there. At this point, I know some of you are going to ask, what about the discharge rate, right? This is a high capacity low discharge rate cell. This is a low capacity high discharge. This is designed for power tool. This is not. These 18650 cells, they are designed to maximize capacity, not discharge rate, and therefore they only discharge at 5 amp each. I got 2 in parallel, and therefore maximum discharge rate of this pack is only 10 amp. And that means I can only use this battery for tools that don't require a lot of power. For example, a flashlight or a Bluetooth speaker. There are tools like impact driver, drills, and saw. They require a lot of power, and therefore this battery is not suitable for these tools. But I'm just gonna go ahead and test this battery with my impact driver and see how it can handle the stress. I will show you that later in the video. Here is the original battery, and this is what the original BMS looks like. And it is extremely simple. All I did is to desolder the main terminal here and here. There's a balance wire here on this side and another balance wire here on this side, and that is it. It's extremely simple to modify. And this is what it looks like after I put the new cells on. And then I just slap on the original bottom cover. Now there is a gap around the battery, so I'm just going to use foam to fill in the gap. And also the original screw is too short and it won't reach, so I'm going to have to use a longer screw for this. To screw the case together, I can only find 2 wood screws that is long enough for this. The other 2 screws, they are machine screws. I tried size 632, which is this one here, but it's a little bit too fat and it starts to crack this plastic here. So I try a smaller screw. This one is size 440. It has finer threads because it's a machine screw, but it works. To seal this gap on the battery, I'm using white EVA foam on the inside because it's not even on the inside. Some part is deeper than the other. So I just want to make it even before I put another layer of EVA foam. Now on the outside, I'm just going to use black EVA foam, and it will go in like so. Here it is. I've got EVA foam all the way around. Isn't sheer beauty? It's moment of truth. Let's see if it works on a regular charger. Yep, here we go. It's charging. Now let's try and charge it using USB-C. Yep, there we go. It's charging. Now let's try it on a flashlight and see if it works. Yep. Let's try the impact driver. It's moment of truth. Let's put this to the test, shall we? I'm going to put the battery under load, and I have 20 screws on my piece of wood here. I have my meter here with a temperature sensor, and I'm going to put the probe right inside the battery, and we are going to just tape it on like that. So we're going to have a real-time monitor of temperature of the battery. So right now it's displaying temperature in Celsius. So we're at 29 degrees Celsius right now. Wow, I'm totally surprised. After 10 screws continuously, the temperature goes from 29 Celsius to 31 Celsius. So that's only 2 degrees increase in temperature. Now it's 30 degrees Celsius. That's amazing. Now let's try another 10 screws and see what happens. So as you can see, the temperature went up to 35 Celsius and then it quickly goes back down to 33. So that's amazing. It actually works. I mean, 10 screws, 20 screws continuously. And we only reason about 4 degrees Celsius. Now, I want to check on the motor because it's kind of warm up here and see how warm it is in there. Yep, I can feel the warmth coming out of here. So even the motor is warmer than the battery. 41 Celsius already. Wow. That means it works great. I didn't expect this at all. I mean, it's not even warm. Wow. I think I know why this works for my impact driver. This battery, even though it's rated at only 5 amp continuous, in burst mode, it can put out about 10 to 12 amps. That means that for a short period of time, I can get over 20 amps with this battery. And I think it works for impact driver because when you drive screws, you don't drive screws continuously, right? Very rarely do you drive 20 screws continuously. You drive like a few screws and then you stop, right? And then you do something else and then you drive a few more screws. And therefore the battery has time to recover until you use it again. I salvaged these 18650 cells from USB power banks. So basically I got a 7 amp hour battery for free. Well, actually, I can't even buy a 7 amp hour battery for this tool line even when I have money because the maximum capacity that Skil 12 volt power tool has is only 4 amp hour. That's it. And that's all I have for now, folks. Thanks for watching and I will see you again in the next video.